Good morning, students. Welcome back to the science class. Last class we discussed up to how are electrons distributed in different orbits. How are electrons distributed in different orbits? The distribution of electrons into different orbits of an atom was suggested by Bohr and Barry. Then we calculate the number of electrons in different energy levels. The maximum number of electrons present in a shell is given by the formula 2n square, where n is the orbit number, first orbit k shell. So we can apply this number in the formula 2 into number of shell 1 square is equal to 2. Second orbit is L shell, 2 into 2 square 8. Third orbit M shell, 2 into 3 square 18. Fourth orbit 2 into 4 square 32, so on. The maximum number of electrons that can be accommodated in the outermost orbit is 8. Electrons are not accommodated in a given shell unless the inner shells are filled. That is, the shells are filled in a stepwise manner. Today we are going to learn about valency. What is valency? Valency is the combining capacity of an atom of an element. What is valency? Valency is the combining capacity of an atom of an element. In the last class, I showed one diagram. The hydrogen, the outermost orbit contain only one electron, helium contain 2 electron, lithium 1 electron, beryllium 2 electron, boron 3 electrons, carbon 4 electrons, etc. So electrons present in the outermost shell of an atom are called valence electrons. Here we can see the difference between valency and valence electrons. Valency is the combining capacity of an atom of an element. The electrons present in the outermost shell of an atom are called valence electrons. If an atom's outermost shell is completely filled, they are inert or least reactive. Their combining capacity or valency is 0. If an atom outermost shell is completely filled means the outermost shell should contain maximum 8 electrons. Maximum 8 electrons. If the outermost orbit, if it contains 8 electrons, the atom is more stable in nature. If the electrons number below 8 means the atom is unstable in nature. If an atom's outermost shell is completely filled, what's the meaning of complete filled? The outermost orbit should contain 8 electron means that is completely filled. They are inert or least reactive and their combining capacity or valence is 0. Of the inert elements, helium atom has 2 electrons in the outermost shell and the atoms of other elements have 8 electrons in their outermost shell. Helium is also stable in nature because the helium totally contains 2 electrons. The 2 electrons are found in outermost orbit. Helium have only one orbit, the center nucleus. The nucleus is surrounded by only one orbit. That orbit contains only 2 electrons. So it is stable in nature. Already we know the first shell should contain 2 electrons. You know the formula 2n square. First orbit 2 into n, number of orbit, first orbit. So 2 into 1 square is equal to 2. If the outermost orbit contains 2 electrons, that also stable in nature. Of the inert elements, helium atom has only 2 electrons that is present outermost shell. So atom of the other elements have 8 electrons in the outermost shell. Except helium, all other atoms, they have 8 electrons in their outermost shell. Atoms having 8 electrons in their outermost shell is having 8 means octet configuration. Octet configuration. So the atom is stable in nature. 8 electron is there means outermost shell. Outermost shell, if it contains 8 electrons, that is stable in nature. If an atom's outermost shell is not completely filled, what's the meaning of not completely? If it below 8 electrons, not completely filled, it is not stable. It will try to attain stability. So this atom is try to attain stability either by losing or gaining or sharing electrons with other atoms to attain octet configuration. For maintaining the stable nature, atom, it will sometime it will lose or gain or share the electrons with the other atoms. If an atom of the outermost shell is not completely filled, the number of electrons lost or gained or shared by an atom to attain octet configuration. What is octet configuration? Outermost shell contain 8 electrons. That is octet configuration. The number of electrons lost, gained or shared by an atom to attain octet configuration is the combining capacity or valency of the element. Valency of the element. The test tube page number 50. There schematic atomic structure of the first 18 elements are there. You should study that 18 elements. Example, hydrogen. Outer only one orbit is there. The orbit contains only one hydrogen. So hydrogen. Lithium. Lithium, only one electron is there. Only 2 orbit. First orbit 2 electron. Second orbit only 1 electron is there. Sodium. Sodium also only 1 electron is found in the outermost orbit. So hydrogen, lithium, sodium atoms can easily lose 1 electron. If they lose their electron, they become stable. Why? This sodium second orbit contain 8 electrons. Lithium second orbit contain 2. First orbit contain 2 electrons, etc. So for attaining that atom stable, hydrogen, lithium, sodium atoms are easily lost their 1 electron. So their valence is 1. Magnesium can easily lose 2 electrons. So its valence is 2. Aluminium can easily lose 3 electrons. So its valence is 3. Page number 50. The schematic atomic structure of the first 80 elements are there. You just see that. Then carbon share 4 electrons. So its valence is 4. Fluorine can easily gain 1 electron because the fluorine, the outermost shell contain 7 electrons. If it gain 1 more electron, that fluorine becomes stable in nature. Oxygen can easily gain 2 electrons because the outermost shell of the oxygen contains 6 electrons. How many electrons they need? 2 more electrons. So its valence is 2. Nitrogen can easily gain 3 electrons because the outermost shell of the nitrogen contains 5 electrons. How much electrons they need more 3 more. 3 more means it will attain 8. So its valency is 3. How can we calculate the valency electrons? Carefully listen this one. In your textbook, page number 51, there one tableau column is there. Valency is also there. How can we calculate the valency? If the number of electrons in the outer shell is between 1 to 4, the compound is said to have positive valency. See page number 51, tableau column, hydrogen. The outermost shell of the hydrogen contains only one electron, so its valency is 1. If the outermost shell contain the number 1 to 4 electrons are there, means that is a to positive valency. For compound with electrons above 4, if the outermost shell name 5, 6, 7 is there, means how can we calculate that valency? You should subtract these numbers from 8. These numbers from 8. For example, nitrogen outermost shell contain 5 electrons. 5 electron is there. How much electrons need to complete that orbit? 3 more electrons. How we will get the answer? Total 8 electrons need. The outermost shell should contain 8 electrons for filling. So here the nitrogen only 5 is there. 8 minus 5. So remaining 3 electrons need. So the valency is 3. If the outermost shell contain 1 to 4, here hydrogen only 1 electron is there. So valency 1. Helium, valency is only 1 orbit is there, 2 electron. So valency 2. Lithium, only 1 electron is found in the outermost orbit. So valency is 1. Beryllium, 2 is there. Valency 2. Boron, 3 electron is found in the outermost orbit. So valency 3. Carbon, outermost shell contain 4. So valency 4. But up to 4, you can directly write that value. The valency 1 means 1. Outermost shell contain 1 electron means 1. 2 electron means 2. 3 electron means 3. 4 electron means 4. But after 4, above 4, if the outermost shell contain 5 means, how can we calculate the valence electron? You should subtract these electrons from number 8, because outermost shell should contain 8 electrons. So we should subtract the number 8, this number from the 8. Nitrogen contains 5 electrons. So how can we calculate 8 minus 5? What is the valency? 3. Like this, oxygen, outermost shell contains 6 electrons. How can we calculate the valency? 8 minus 6. Up to 1 to 4, we no need to subtract from 8. Directly we can write the number of electrons that found in the outermost orbit. That directly we can write. But above 4 is there, means we should subtract this number from 8. Oxygen, 6 electron is found in the outermost orbit. What is the valency? 8 minus 6 equal to 2. The next one is atomic number and mass number. Dear students, please note down in your notebook. It is very important problem they will ask. Atomic number of an element is the number of protons. Keep it in your mind. Don't forget, this is a basic chemistry. Atomic number means number of protons present in the nucleus of an atom. All the atoms of an element have the same atomic number. Hydrogen, atomic number 1, which means only 1 proton. Number of proton denotes atomic number. Helium, atomic number 2, which means 2 proton. Lithium, atomic number 3, 3 proton. atomic number means it is equal to protons. What is mass number? Atomic number is designated by the letter Z. Mass number. What is mass number? Mass number is designated by A. The mass number of an element is the sum of the number of protons and neutrons. It is the sum total of number of protons and neutrons together present in the nucleus of an atom is called mass number. Atomic number, it denotes only proton, but mass number means it is the combining product of both proton and neutron. Mass of an atom is mainly the mass of the proton and neutrons. Example, carbon, mass number 12. It contains 6 protons, 6 neutrons. Aluminium, mass number 27. Mass number it contains both proton and neutron. 13 protons, 14 neutrons. Sulfur, mass number 32. 16 proton, 16 neutrons. Here see in the notation of an atom, the atomic number and mass number is written as like. Here one example is there, nitrogen 14 7. In the up 14 is there. 14 means mass number. What is mass number? This mass number contains both protons and neutrons. Down 7 is there. 7 means atomic number. Atomic number means number of protons. Sometimes they will ask what is the number of neutrons. How can we calculate mass number minus atomic number? Mass number means it contains both proton and neutron. It minus atomic number means number of proton. So we will get answer. Here what is the number of proton? Atomic number is down 7. Number of proton 7. Already you know atomic number means proton. Mass number, proton and neutron is there. So 14 minus 7. That time you will get the neutrons number, 7 neutrons. The next one is isotopes. Isotopes are atoms of the same element having same atomic number but different mass number. See here, hydrogen, the same element, hydrogen. 3 type of hydrogen is there. Hydrogen has 3 isotopes. They are protium, deuterium, deridium. This isotopes is based on the number of atomic number and mass number. What is isotopes? Isotopes means the atom of the same element having same atomic number but different mass number. Same, and see here first protium, hydrogen, 1 up 1, down also 1 is up 1 means that is the mass number, down means that is the atomic number. Atomic number means proton. How many protons found in the protium? Only 1 proton, atomic number. How many neutrons are there? Up how much is there? 1. That is the mass. 1 minus 1, 0. Then deuterium. Up 2 is there. 2 is the mass number. Mass number it includes both proton and neutron. Down 1 is there. 1 means atomic number. Atomic number is the proton. How many deuterium? How many proton is there? Only 1 proton. How many neutron is there? 2 minus 1. Mass number minus atomic number. So we will get 1. Neutron also 1. Deridium. What is deridium? Mass number 3, atomic number 1. How can we calculate the number of proton? Number of proton, atomic number is 1. That is proton. Mass number of neutron 3 minus 1 equal to 2 is the number of neutron. So hydrogen, 3 type of isotopes, but they have same atomic number. See atomic number 3 type of hydrogen, 1 atomic number 3, but where it different, they have different mass numbers. Deuterium 1, deridium, protium 1, deuterium 2, deridium 3. Mass number is different. Another example, carbon has 2 isotopes, C12 6. See 14 6. See atomic number is same 6 6. Mass number is different 12 14. What is the proton number 6? What is the neutron number in C 12 6? Neutron number 12 minus 6 equal to 6. Neutron is equal to 6. C 14 6. 14 is the mass number. 6 is the atomic number. What is the neutron number? 14 minus 6 equal to 8. 8 neutrons, 6 protons. Chlorine has 2 isotopes. 35 17 chlorine, 37 17 chlorine. See atomic number is same 17 17. Mass number is different. This is isotopes. Can you calculate that number of proton and neutrons? The next one is isobars. Isobars are atoms of different elements having different atomic number. Isotope means atoms of same element having same atomic number but different mass number. Isobar means atoms of different element having different atomic number but same mass number. These pairs of elements have the same number of nucleons. Example, see calcium argon. See the mass number up 40 40 mass. See down atomic number is different 20 18. Calcium different element. One is calcium, another one is argon. What is the how many protons found in the calcium? 20. How many neutrons found in the calcium? 40. Mass number minus atomic number. 40 minus 20 equal to 20. 20 neutrons. Argon. Mass number 14, atomic number 18. Number of proton 18. Then neutron 40 minus 18 22. Then another one example, iron and nickel. See atomic number is different. Iron 26, nickel 27. But see the mass number same 58 58. What is the proton number of iron? 26. Proton number of nickel 27. That is atomic number. Then mass number 58 for both. Then what is the neutron of iron? 58 minus 26. Then what's the answer? 32. Then 58. The nickel neutrons, number of neutron is 58 minus 27. Dear students, you study these definitions thoroughly. Isobar, isotopes, atomic number, mass number. Very simple one. Don't get confusion. So study thoroughly. Thank you.